Good afternoon, I am Mr. H. Thank you for joining me. In this video, we're looking here at two mixture problems, or you can call them concentration problems. And we're starting here with this one. We have a 5-gallon 30% solution. We're starting with a 5-gallon 30% solution, which is of acid, that is to be strengthened to 50%. Volume must stay the same. How much of that existing 5-gallon 30% solution must be removed and replaced by pure acid to achieve this concentration of 50%? Exactly how you're reading it is exactly how you will generate your expression. And remember, when you're talking about mixture and volume, you're always looking at concentration and volume coming together. Concentration times volume, that's exactly how it is. CV or VC in a product relationship. We're starting here with 5 gallons of 30%, which you can write as 0.3, because 30% is 0.3. How much of this existing solution should be removed? How much of this in terms of volume of that existing solution, 30%, and then replaced by pure acid? The amount you're removing is exactly the amount you're adding, because you still want to end up with the same volume. Volume stays the same. How do you generate pure acid in terms of concentration? Well, it's 100%, which means it equals a 1. To give you your outcome, 50% of 5 gallons. 5 gallons of 50%, 0.5. Remember, volume, concentration, volume, concentration, volume, concentration, volume, concentration. Everything stays good that way. Now all you have to do is solve for x. We have a 1.5 here. We have a minus 0.3x. We have a plus x is equal to 2.5. So we have 1.5 plus 0.7x is equal to 2.5. 0.7x is equal to 2.5 minus 1.5, which you know is a 1. X is equal to 1 divided by 0.7. Whatever that will be, which is basically 10 over 7, but it'll give you an answer here in decimals. We'll do 1 divided by 0.7. We're getting 1.428, which I'll round to 1.43 gallons. What does this 1.43 gallons mean? What it means is from this existing 5-gallon 30% solution, you're removing 1.43 gallons of that, but then you're replacing it by 1.43 gallons of pure acid. You'll still end up with a final volume of 5 gallons, but your concentration will be increased from 30% to 50% simply by adding 1.43 gallons of pure acid and removing the same amount before you did that. And that's exactly how you handle it. Again, volume times concentration, volume times concentration, volume concentration, volume concentration. This is how much you removed, then this is exactly how much you added of pure acid to get your desired outcome. And we will look at one more question now for this video. Let's look at the second question. We have a 5-gallon bucket which is 30% acid solution. How much pure water must you add to that bucket of solution to make it 25% to dilute it? It's not a very hard question. Again, as you read it is how you write it. A 5-gallon bucket is 30% acid solution. It's always volume times concentration or concentration times volume. We can do volume times concentration, 0.3. 30% is 0.3. How much pure water must you add? X. That's your volume. But what is water in terms of acid solution? If you have pure water, it's 100% water and it's 0% in terms of acid. While water is 100% in terms of purity of water, in terms of acid it's 0%. So you have x times 0. This is being added to this to give you a solution that's 25%. But what will be the resulting volume? It'll be 5 plus x times the concentration. The desired outcome, what you want, is 0.25, and that right there is exactly how you would do it. This is what you're starting with, this is the amount of pure water you're adding, and this is what your final volume will be with the final concentration. 5 times 0.3, 1.5 plus 0 is equal to, multiply that. You'll have 1.25 plus 0.25x. All you have to do is solve for x. You have 0.25x is equal to, take this on the other side, you'll have 0.25. And then x is equal to 1. 0.25 divided by 0.25 is 1. But what does this 1 represent? It means 1 gallon of H2O or pure water. Pure water. 1 gallon of pure H2O or water is exactly how much you would add to 5 gallons. Your resulting solution will be 6 gallons, but it will become diluted by means of that 1 gallon of pure water. It will dilute from 30% to the 25%, which is what you have right over here. So this right here is your answer. 1 gallon of pure water must be added to dilute the 30% to 25%. And again, I'll say you'll have a resulting volume of 6 gallons, and you started with 5, but you'll have 6 at the end. And that's it for this particular video. Thank you for watching. And before I actually say bye, just remember this. When you're talking about these type of questions, pure water is always 0% in terms of the chemical or the concentration you're looking at. with regards to what you're starting off with in terms of solution, but pure of something else is always 100% or 1. If you see pure water is being added to an existing solution, you're looking at a concentration in terms of that solution of 0%. But if you're seeing pure acid or pure salt or pure water, then in terms of that you have 100% or 1 with regards to the solution that you're trying to create. So keep that in mind, 0 versus 1. Here we have pure water, so I'm using 0. In the previous question we had pure acid, so we brought in 1. Thank you for watching. Have a good day.